This video has been made as a part of assignment 5 of the course Nature Inspired Computing. In this video, we will be solving grading using hierarchical clustering. Let us have a look at the problem statement. We are provided with the data of 26 students and each student has a unique ID from A to Z. We are also given marks of each student, which lies in the range from 0 to 100. For example, the marks of student A is 60.7, marks of student H is 42.3 and so on. The task is we need to assign grades to these students depending upon the marks that they have obtained. In the part A, there are 4 types of grades A, B, C and D. And in the part B, suppose the institute has decided that if the number of students are more than 20, then there must be at least one F grade as well. But in our case, the number of students are 26, which is greater than 20. Hence we must have at least one F grade. Therefore, we have A, B, C, D, and F grades. Here we will assume that A is the best grade, B is the second best grade, and so on, where F is the worst grade. That is, a student with the highest marks should get A grade, and the student with lowest marks should get F grade. Let us have a look at the hierarchical clustering algorithm. In the hierarchical clustering algorithm, I have used a single linkage method. Let us define a cluster. So a cluster is a set of one or more input data which are identified as one group by the algorithm. Now let us define the quantity distance between the input. Here D represents the distance and X and Y represents input data. Here X and Y will be marks of students and the distance which I have defined is Euclidean distance, that is I take the absolute difference between the marks. Now let us define the quantity called distance between clusters, which is denoted by capital D. Here A and B are two different clusters. For calculating this quantity, we iterate over all the points in the first cluster and take its pair with all the points in the second cluster and take the minimum distance between these 2 points. It means that we are taking the closest points where one point lies in the first cluster and second point lies in the second cluster. This is defined as the distance between the two clusters. Now let us have a look at the steps which are involved in the algorithm. First, we assign each input data to one cluster. Then we pick two clusters with the minimum distance d, and then we merge those two clusters. Now by doing this, the number of clusters will reduce by 1. Then we recalculate the distances between all the new clusters, and then we repeat step 2 until all the input data points are a part of a single cluster. We need to do this process n-1 times so that all the input data points become part of one cluster. Here, one thing to notice is that if we use a different kind of method instead of single linkage, or if we use different kind of distance metric instead of Euclidean distance, then the answer would be different. The other type of methods are complete linkage or average linkage. Here I've used single linkage. The algorithm was implemented in Python using libraries like NumPy, Pandas, TQDM, Matplotlib, and SciPy. Now let us have a look at the retrogram obtained. So this is the retrogram that was obtained after running the algorithm. Here the x-axis represents the students and their respective scores. For example, for the student which had the ID U had score 39.2. Here the y-axis represents the distance at which the two clusters got merged. For example, the cluster which contained students Q and S and the cluster which contained only the student Z got merged at the level which is around 4.4. Now the best part about the redogram is that we can set a threshold level which will be a horizontal line, and then we can get any number of clusters that we want to solve our problem. Now let us have a look at the part A. In part A, we need to assign 4 grades to the students which are A, B, C, and D. Hence, we need to find 4 clusters. Now, if we put a threshold at this level, then we can find 4 clusters. In the first clusters, all the points which are in the pink will be allotted. In the second clusters, all the points which are in this sky blue color will be allotted. In the third cluster, the points in the red will be allotted. In the fourth cluster, all the points in the green will be allotted. Here, one thing to note is that all the students in the first clusters, in the pink cluster, have marks is strictly greater than all the students in the second cluster, and all the students in this cluster have marks greater than all the students in this cluster, and so on. Hence, these are the students with the best marks, and these are the students with the worst marks. Therefore, we can assign A grade to these students, B to this, C to this, and D to this. Hence, we do exactly that. Now, this table represents the final grade which was allocated to the students. The table has been sorted by the marks obtained by the students. Here we can notice that the students which had the highest marks got A grade, and then some students which have marks lower than these students got B grade, and the students which had lower marks than B grade students got C grade, and finally the students which had least marks got D grade. And this clustering was done using the algorithm. Now let us have a look at the part B. In part B, we need to assign 5 grades A, B, C, D, and F. Hence, we need to decide a threshold such that the number of clusters are 5. So if we reduce the threshold level, then we can find 5 clusters. The only difference between the part A and part B is that instead of this green part, one cluster, it has actually been split up into 2 clusters now. So now Q and S are part of one cluster, and only Z is part of another cluster. Hence, we have Z, which is one cluster, Q and S, which is another cluster, and then this red part, which is the third cluster, and then the students in the sky blue color, which are the fourth cluster, and the students in the pink color, which are the fifth cluster. Therefore, we have 5 clusters now. They also satisfy the property that the students in these clusters have the highest marks, followed by the students in these clusters, followed by the students in this cluster, and then these 2 students, and then last this student. Hence, we can assign A grade to these students, B to this, C to these students, D to these two, and F to only the student which has the ID Z. Finally, this table represents the grading which was done using the 4 grades A, B, C, D, and F. The only difference between this table and previous table is that this green cluster got split up into 2 clusters, and the student Z got F grade, and we can notice that this student had the least marks. Hence, we have solved both the parts A and B. Thank you.